Hi guys, this is Mr. Coumbe. Let's do a bit of a harder gas stoichiometry problem. Pause this video so you can read the actual question and let's solve this problem. Here you have an actual lots of information. However, this problem, the reaction is not occurring at STP. So STP is standard temperature and pressure, which is 273 Kelvin or 0 degrees Celsius, and at 1 atmosphere. However, this is occurring a little bit of a warmer temperature, 20 degrees, and at a much heavier atmosphere, much more intense atmosphere, 25 atmospheres. And you're also told how much sulfuric acid you have that will react with this ammonia gas. So let's figure out how much, first, how much sulfuric acid we actually have. So the number of moles first of our sulfuric acid, so H2SO4, is 150 kilograms. So don't be fooled by that. 150 kilograms, we need to convert that into grams because our molar mass, and that's a comma there, is in grams per mole. So it's going to be 150,000 grams. And the molar mass of sulfuric acid is about 98.086 grams per mole. So we're going to have lots of sulfuric acid. So in this reaction, we actually have about 1.53 by 10 to the 3 mole. Okay, 10 to the 3 mole. So that's about 1,530 moles of our sulfuric acid. So now, because we have this reaction, we can figure out the number of moles of our ammonia. So the number of moles of our ammonia gas is going to be, if we look at the ratios, is going to be twice the number of moles of our sulfuric acid, which is approximately going to be 3.06 by 10 to the 3 moles. Awesome. Now we can use, so now that we know that, we can figure out, using Avogadro's law, the volume of our ammonia, which is simply going to be 3.06 by 10 to the 3 times 22.71, which is 6.95 by 10 to the 4 liters. Okay? Now, because this is 6.95 by 10 to the 4 liters, it is at STP, which is standard temperature and pressure, being 273 Kelvin and 1 atmosphere. However, our reaction did not occur at STP. It occurred at 20 degrees Celsius or 293 Kelvin and at 25 atmospheres. So we are going to need to use, and I'll put it in this yellow color, we're going to need to use the combined gas law, which is P1 V1 over T1 equals P2 V2 over T2. Let's fill in the values. At STP, the pressure is 1 atmosphere, and I'll put in the unit for now. And we have a volume of 6.95 by 10 to the 4 liters, and that is all over 273 Kelvin, which is going to be proportional to 25 atmospheres times the second volume, which I don't know, at 293 Kelvin. If we rearrange that to get the second volume, it's actually 1 atmosphere times 6.95 by 10 to the 4 liters times 293 Kelvin divided by 273 Kelvin times 25 atmospheres. So it actually, it all ends up being 2.98 by 10 to the 3 liters, which actually makes sense because at STP we have an enormous volume of ammonia needed, and here at this much heavier atmosphere we have much less. We have only 2,980 liters as opposed to 69,500 liters of ammonia. And here we go, problem solved.